Hi, good Monday morning anyway. Today we're going to be talking about circles. And circles are everywhere. They have to be everywhere because without circles, we would have no existence actually. And that's kind of an odd thing to say, but it's true. I mean, look at the circles around you. Look around where you are. There's circles everywhere. Here's my coffee table. There's I don't know how many circles on this coffee table. Well, there's the assignment we're going to be doing. Shape of a pencil. My dog's eyes. And I don't know if you've noticed her teeth. Anyway, I've got a tape measure here. There's a circle. Inside is a spool that the tape comes out from. And inside that, there's a circular spring. So we all got circles there. I got a watch. It's got a circle on it. My remote, it's circular. It has a semicircle on it with little circles drawn in on it. The shape of the cord of a charging cord. There's circles. And I'm kind of a sloppy person, so I eat in the living room. Salt shakers, circular. Those are some coasters. Those are circular. My empty bottle of lemonade, circular. There's the buttons here, circular. They're just everywhere. Without a circle, we wouldn't have wheels. And therefore, we couldn't go anywhere. And if you'll notice, anything that has to do with liquids, such as glasses or jugs of juices or milk, there's no square corners on those. All the containers are circular. They're rounded. Here's my coffee cup. All glasses are round. There's hardly any square glasses. They make them, but they're kind of rare. And my Gatorade bottle, it's round with a round top. You imagine it with a square top, you could screw it on. Look at the shipping containers of oil. They're either round or they're elliptical, which is round-ish. They're circular-ish. Look at the containers that hold oil. These oil batteries. They're all round. Every one of them. They don't make square oil batteries. The tanks are, the handling devices. They're all pipes, which are round. And there's a reason for that. If you drop a water from a height in an eyedropper, and you watch it, it forms a circle. It will always do that because the circle is the strongest geometric shape that we know of, that probably exists in all of nature. And so we're going to be doing some things about circles. And circles always have to do with pi, P-I. It's a Greek letter, and I'll show you how that's drawn. Most of you probably know that already. But to get the number pi, and it's on every calculator anymore, it's actually a ratio. It's a fraction. And pi is, you can find pi by dividing the circumference of a circle or the outside of a circle by its diameter. And why somebody thought this up, I don't know. But it's a constant that relates to every circle and every partial circle. So you're going to find pi all throughout nature. And without pi, I don't know, our number system and our mathematical systems would be vastly different. And the way we calculate areas and circumferences, things like that, it might not even be possible. So we're going to do some circles. Most of everything you need to know about circles has to do with these formulas. Right? The area of a circle is equal to pi times the radius squared. Okay, the circumference of a circle is equal to 2 pi r. And 2 times r is the diameter. So the circumference also equals pi times the diameter. And so if we want to find out the diameter, all we have to do is divide by pi, the circumference by pi. Now, from these formulas, we can also get some more things, because the assignment's going to ask, okay, well, find the radius, given some information here. So from here, the radius, to find that, if we know the circumference right up here, then to isolate the radius, all we got to do is divide by 2r. So the radius is equal to the circumference divided by 2 pi. And we know that because when you have a circle, here's the radius. The distance around is the circumference. And if I draw a line all the way through the circle, that's the diameter. And so we're going to need to find ratios or comparisons against all of these different unknowns. And so the radius can be divided, we can find that if we know the diameter. Because we know that the diameter is equal to 2 pi. Or the diameter is 2 times the radius. Okay. Two times the radius. And so we also know that the radius, if we now isolate r, we divide both sides by 2. And so the radius is equal to the diameter divided by 2. All right, so we've got 6 main formula that we need that's going to help us out on this. Okay, here's the worksheet. Now, if we had calculators, we'd be doing this a little different. We'd be using pi as just pi that's in the calculator. And if you'll notice on any calculator, like this is a TI, right up here is pi. And we wouldn't have to use 3.14, but you could do that. And instead of using 3.14, we're just going to use pi. And we're doing this because we don't have any calculators. All right, so that's what's going to make these easy. Pi actually makes life easier. If you don't, because you don't have to use numbers, you can use a symbol, and it cuts down on the amount of effort that you have to put in. All right, so the area, we know that. We've got to calculate the radius, the diameter, the area, and the circumference. Well, we know the area. All right, so now to get the radius, let's do that. So we know the radius. We also, well, let's add another formula here. When we know the area, but we don't know the radius, all we do is isolate r again. So there we have to divide this side by pi. So r squared pi equals area. All right, so we're going to divide the area by pi, because we're trying to isolate r. That's all we're doing. And whatever we do to one side, we got to do the other. Divided by pi. That leaves r squared equals a over pi. But we have r squared. We want r, so we have to take the square root of both sides. And so r is equal to the square root of the area over pi. So with that, we know the area. So the radius, all we do is plug it in. That's why we have this formula sheet. So we've already done all the calculations probably that's needed for this these few problems here. I think there's 9. All right, so the radius is equal to the square root of the area divided by pi. So that's the square root of 12.56 divided by pi. And that's the radius. That's as close as we need to get. Now, with a calculator, all we would have to do is plug this in and it would give us the number. But without having to do all that, without having to be stuck with actually finding a number, here's what we're doing. All right, now the circumference the same way. All right, we know that the circumference is equal to 2 pi r, or pi times d. All right, we know r, so let's just use that. All right, so we know that it's going to be 2 pi r. I will see y'all on Wednesday, and we're going to be doing some more circles tomorrow that are not going to be much different than this. And if you so I want you to keep the formula sheet that you have. Don't turn it in. Hold on to it, and because we're going to be using it tomorrow. See this guy right back here? Yeah, that's my Longhorn. His name's Steve. Bye, Steve. Bye, guys. See you Wednesday.